when you're naming ionic compounds, the first thing you want to do is figure out how many elements are involved. If there's two elements, then there's two options. Either it's a group 1, 2, or 13 metal, or it's other metals. Either way, you have a metal, you have a non-metal, and there's only two elements. So there's a system for these. The other type is three or more elements. And the way you identify that is that you look for capital letters. In case you have not memorized your elements, you just count capital letters. So here you have 1, 2, 3 capital letters. That tells you have 3 elements. So each of these requires a different system. So the first I'm going to go over is the group 1, 2, or 13 metals. For these, all you have to do is name the metal, sodium, name the nonmetal, and change the ending to IDE. So chlorine actually becomes chloride. Oxygen becomes oxide. So you keep the first syllable, drop the rest, and put IDE as its ending. So nitrogen, nitride. Phosphorus, phosphide. Each time you notice, I just kept the first syllable, dropped the rest, put IDE. Alright, so next one is magnesium chloride. Notice, all I did, magnesium chloride. Just name the metal, name the nonmetal, or the anion, and you're done. Same thing here, calcium oxide, and same thing here, aluminum phosphide. In each situation, all I did, name the metal, name whatever it's attached to, and I'm done. Alright, now the other metals. Here it's not as simple. For these, the charges are always going to be 1, 2, or positive 3. So group 1 is always positive 1, group 2 is always positive 2, group 13 is always positive 3. So you don't have to specify a charge because everybody knows what it is. For these, they can have more than one possible charge. So what you need to do is figure out the charge. The way you do that, you uncrisscross these subscripts. So this 2 actually behaves as the charge on the cation. Remember, the first element is always a cation. It's always positive. So even though I just brought a 2 up, I know it's a positive 2 because it's the first element. Same way, we know the second element is always going to be a 1 minus because in this situation, it's an anion, and anions are always negative. There's no number here, so you assume it's a 1. So if you don't see a number, assume it's 1. So what do we call this? Well, we named the metal. We've specified a charge with a Roman numeral. Named the anion, and we're done. In case you're not familiar with your Roman numerals, Roman numeral 1 is positive 1. Roman numeral 2 is positive 2. 3 is positive 3. And this one, IV, is positive 4. There's 5 and 6, but these are the more common ones. Alright, we're going to do the same thing for this. Cu, 1 plus, and O, 1 minus. Now, there's a problem here. We know for a fact oxygen, or oxide in the situation, is not negative 1. It's actually negative 2. So what happened? Well, it turns out when you're crisscrossing, using the crisscross method, you have to reduce it down to the lowest possible number. So to undo that, we need to multiply by whatever number gives the correct charge on the anion. So that's Cu, 2 plus, O, 2 minus. So you have to understand that when you're doing these types of compounds, the ones involving other metals, you get the charge from the anion. It's always the case. You first figure out the charge of the anion, and from there you can figure out the charge of the metal usually. And you have to remember that these numbers are sometimes reduced, so you have to unreduce them. So this is just copper, Roman numeral 2, oxide. Alright, next one. We have Sn, 2 plus, O, 1 minus. Same problem, right? we have that negative 1, so we're going to multiply this by 2, this by 2. This becomes SN4 plus O2 minus. So we're left with tin 4 oxide. Alright, same thing here. Pb4 plus I minus. Iodide is group 17. That is a negative 1 charge. In case you don't know your charges based on groups, 15 is a negative group, I'm sorry, negative 3. 16 is a negative 2 charge, and 17, all elements there are negative 1. So if you look in the periodic table, and those are the charges. So this is actually the correct charge, so we are done. Lead 4 iodide. Alright, that leaves us with the ones evolving through more elements. So how do you name these? Well, like I said, you could either memorize your polyatomic ions. There's about 25 common ones. Or if your teacher allows you, you could look at a chart. It's really up to the situation, but it's really easier if you just memorize them, because then you recognize them a lot faster and makes things simpler. Alright, so how do we name this? Well, name the metal. This is group 1. We don't need to do the whole uncrisscross thing. And the polyatomic ion here is phosphate. Phosphate is just PO4 with a negative 3. Polyatomic ions are basically two elements, one of them nonmetal, the other one oxygen, combined and having a charge. They function as a unit. So PO4 is the only way to write phosphate. You can't write it as PO or PO2 or anything. This is the only way to write phosphate. The reason I say that is because you can't touch this bottom number, and that becomes important in a second. We'll see that. Alright, so next one. It's not group 1 or 2 or 13, so that means you do have to uncrisscross. So SN2 plus PO4 3 minus. Well, we know phosphate's negative 3, so just like over here, we're able to verify the charge of the anion is correct, so we don't need to do any kind of multiplying. So we're just going to name the metal, which is tin 2 phosphate. Now, in case you didn't notice, this one has a set of parentheses. This did not. What's the difference? Well, here we needed more than one phosphate, and the only way to show that you need more than one polyatomic ion is with parentheses. And in this situation, we have a 2 on the outside. That's how many phosphates it takes. So this is telling you have 2 PO4s. And this is also the number we uncrisscross. If it's inside the parentheses, you can't touch it. If there is no parentheses, you can't touch it. If there is parentheses, then whatever number is on the outside, you uncrisscross that. So just pay attention to that. If you don't see parentheses, don't ever touch that bottom number. Ever, ever. Don't reduce it. Don't do anything to it. And for the next one, we have calcium. Remember, don't touch that bottom number. So how many CO3s do we have? 1, as far as we're concerned here. So that's 1 plus CO3, 1 minus. By the way, you could write it as plus 2 or 1 plus. It doesn't matter. You could do this as well. There's no real, sticky thing to as far as making sure the plus on the front or the 2's in the front really doesn't matter. So in case you see me interchange them or you interchange them, it's not a big deal. Alright, so for this one, we know CO3 is actually a negative 2. So that's 2. We have to multiply by. Same thing with this. So this becomes Ca 2 plus CO3 2 minus. Notice I did not touch that bottom number. Not that I really need to do this. This is not group 1, 2, or 13. So no, I didn't. But the reason I did is just to emphasize that whole don't touch the bottom number thing. But because it's group 2, all I really need to do is just write calcium carbonate. That's what makes that set of elements so nice to work with, because there is no crisscross and there's none of this stuff going on. Metal, polyatomic ion, you're done. Alright, next one. Not group 1, 2, and 13, so that means we have to uncrisscross. So it becomes Pb 2 plus SO4 1 minus. Remember, you uncrisscross the number outside the parentheses. Well, we know sulfate's not a negative 1. It's actually a negative 2. So we multiply that by 2, and that means we have to multiply this by 2, which gives us Pb4 plus and SO4 2 minus. So this becomes lead, Roman numeral 4, sulfate. And we're done. So that's how you name ionic compounds that involve either group 1, 2, or 13 metals, or other metals, or 3 or more elements.